Hi everyone, welcome to my channel. Today we will create linear regression model using insurance dataset from Kaggle. The link to dataset is in the description of this video as well. Here we are creating Jupyter Notebook Linear Regression Volume 1 and put heading Simple Linear Regression using insurance dataset. In linear regression model, we assume that the predictable or independent variable and the predictors or dependent variables have a linear relationship. Similarly, let's discuss the key points we are considering before linear regression. As discussed, firstly, linear relationship. That is, the value of x and y variable have a linear relationship with each other. Secondly, checking the quality of data, such as if the dataset has any missing or null values and if there is any presence of outliers, etc. Further, for linear regression, we are assuming that the dataset verifies with linearity, independence, homoscedasticity, and normality of residues. We will evaluate the model with good evaluation metrics such as R-squared error, and we need to ensure that the model doesn't overfit so that the model generalizes well with test as well as training data and as well as further generalized data. Further transforming of variables or transformation applied on variables if needed for further linearity. Then having domain knowledge of the dataset helps to make sense and get desired form of output from the ML model. Now let's import desired libraries. Importing pandas, then pyplot from matplotlib. We are importing warnings, then train test split and linear regression from sklearn. As you can see in Excel, we are ignoring the warnings using filter warnings function and importing warning library. Now we will read and explore the dataset. We are creating a data frame df using pandas and read CSV by reading the file which is downloaded by Kaggle, and then print the data frame, and let's explore the dimension of dataset. The dataset has 7 rows and 2 columns as you can see in my screen, that is age and premium. Further verifying if the dataset has any null values using isNull and sum function. IsNull function gives us raw output in binary form. Now we will analyze the data distribution pattern across the dataset. First, analyzing age. For that, we are plotting histogram graph to visualize the data pattern with x-axis as age and y-axis as count or frequency. As you can see the graph, the age distribution is uniform across the data set and the age is not repeating in the data set. Similarly, analyzing the premium data across the data set by visualizing in a histogram graph. As you can see the graph, the premium is ranging from 10,000 to 27,000 and the value of 27,000 occurs twice. Now let's analyze the correlationship between the two variables. For this we are creating a scatter plot with age in x-axis and premium in y-axis. As per the graph, the correlationship between age and premium is positive relationship. That is, as the age increases, the premium also increases. The data point shows a linear trend and the data set doesn't show any outliers. Now let's split data into train and test data. We are making dependent variable x with age and independent variable y with premium. Now let's split the data into x-train, x-test, y-train and y-test using train test split with test size as 30% or 0.3. Then quickly checking the values of the new variables as you can see in my screen. After that, we will create linear regression model with model name as LR model. Further, we will fit our model with x-train and y-train using fit function. The output came as linear regression, hence our model has been created successfully. We are creating now ypred variable to assign the predicted value using our linear regression created model, LR model and function predict. Now let's print and see the value of ypred. And now let's compare the actual value y-test with y-pred or the predicted value. After that, we will evaluate our model using R-squared evaluation. For that, we are importing R2 score from sklearn matrix. We are creating variable R2str and assigning R2 score by using R2 score function with y-test and y-pred variable. The R-squared value of our model comes to be as 0.87. That is close to 1, and hence this is a good regression model with good accuracy. Now let's visualize the regression plot of our dataset using Seaborn library. For this, we are importing Seaborn as SNS and plot regression plot for the insurance dataset with title regression plot and x-axis as age and y-axis as premium. As you can see, using red plot function in Seaborn, we plotted a regression plot for the dataset. You can see the output graph where the scatter plot represents the actual data points and the line represents the linear regression slope. In our next video, we will work with multiple linear regression with different data set, and we have a lot of more exciting videos on the way. So don't forget to click subscribe so that you don't miss out on any of the new exciting content. Till then, have a good day and see you next time.